this problem. A 1,500 kilogram car moving on a flat horizontal road negotiates a curve as shown in the figure. If the radius of the curve is 35 meters and the coefficient of static friction between the tires and dry pavement is 0.523, find the maximum speed the car can have and still make a turn successfully. Let us try to illustrate the given. We are given this one, that is the radius is equal to 35 meters. 35 meters. And the static friction is 0.523. We are asked to find the maximum speed or the Pmax. So what are the key conceptualization of this problem? Of course, I have pre-illustrated this. If this is the track and we have a mu, which is the coefficient of the static frictions, to be 0.523, and this will be our centripetal force. Of course, the centripetal force is always acting toward the center of the circle. If this is the centripetal force, we will have a frictional force that will be opposing, no? That will be opposing that. So let us say this is F, which is equal to mu and then multiplied by N. That will be the frictional force. Now let us try to draw the diagram of that car here in the right side. We will have here the weight of the car, which is acting downward, concentrated on its center of gravity, and then we will have here the normal force, which is acting upward, and then we have here our centripetal force C. So let us try to solve this problem. So we sum up forces at X and equate that to 0. We say summation of forces at X is equal to 0, to the right to be positive. So what are the forces acting to the right? The frictional force minus the centripetal force, and that will be equal to 0. But what is the frictional force? That is mu multiplied by N, and we transpose this to the other side of the equation, it becomes positive F sub C. But what is F sub C? F sub C is equal to M. So this will be Bmax now. That's the maximum because we equate that to the frictional force. The key idea here is not to exceed this force. The centripetal force must not exceed the frictional force, otherwise it will not make a safe turn. MB, so this will be maximum, MB max squared over R. So yan yung ating equation. What is left is we just have to sum up forces at Y to get N and equate that to 0. That will be upward positive. N is equal to weight. What's the weight? That is the mass multiplied by 1,500 kilograms multiplied by 9.81. So meron na tayong of course this will be in Newton. I do not write the units anymore. We do not have much space, but this is in kilogram meter per second squared. This will be in newtons. Okay, once we get that or the normal pores here, we will just substitute it there and we will get the value of B. Okay, so how are we going to solve for the value of B in this case? So we say B is equal to, what is mu? Mu is 0.523 times whatever value of that n. It will be substituted here. So we divide that by m, which is 1,500. 1,500. This is in kilograms. Okay, this will be in newtons. Okay, and then what happens to that equation? We still have to multiply that by r, which is 35 meters. 35 meters. Okay, now Newton will be kilogram meter per second squared. So we have to extract the square root because this one is squared. We are going to extract the square root. This one will be meter squared per second squared. Ang lalabas na sagot natin dyan will be, we will be having, this one is meter squared per second squared, and we extract the square root. So meter per second. Let us try to grab the calculator and solve for the values. So we have 1,500 times 9.81, and then that will be 14,715. 14715. So if that 14715 goes here, that will be in newtons. We grab the calculator again, we multiply that by 0.523, that's the mu, times that to 35, and divide that by 1,500, and we extract the square root. So we have 13.4004. 13.4004. That will be our answer. Okay, I hope this one can help.
If my people humble themselves and pray, if they seek my face and humble themselves and turn from their wicked